Hello, today we will have a webinar from SPE Sudan section. Presentation will be about overview and status of EOR field applications worldwide in Sudan. And first, I would like to thank SPE Sudan section for this opportunity to participate in this e-learning series webinars. The outline for this presentation include EOR Overview, EOR Field Applications, and status of EOR worldwide, and status of EOR in Sudan, with some detail of list of EOR projects in Sudan, evaluation and some challenges. And also there will be an estimation of estimated contribution of EOR production in Sudan and potential estimated EOR production from Sudan. And finally, there will be a we will start by EOR overview. As we all know that there is three types of recovery mechanisms: secondary recovery, primary recovery, secondary recovery, and tertiary recovery. By primary recovery, we can reduce a recovery factor up to 30%, and this primary recovery could be by a natural flow or it could be by artificial lift. The secondary recovery mainly for pressure maintenance when we do have a low pressure in some reservoir. This pressure maintenance could be by water flooding or by gas injection, and from secondary recovery we can reduce 30% to 50% from the oil. And finally we have the tertiary recovery, and tertiary recovery we can reduce from 50 to 80% from our oil. And there is many types of tertiary recovery or EOR, such as thermal, gas injection, chemical methods, and others. For thermal, we do have steam injection, hot water and combustion. Also, we have cyclic steam stimulation, also downhole heaters. For gas injection, this gas injection could be by CO2, by hydrocarbons, or by nitrogens. And for the chemical, we have alkaline, surfactant, and polymers. It could be by each one of them or a combination between all of them or two of each of them. EOR has many definitions, so I choose this like three simple definitions for enhanced oil recovery. Enhanced oil recovery can be defined as is usually used to mobilize the residual oil and save the remaining oil as much as possible after using primary and secondary recovery. And also, EOR can be defined as a target for the remaining oil and used to produce the oil which cannot be produced by primary and secondary. The definitions with EOR is a set of activity or techniques designed to increase oil recovery after implementation of primary and secondary recovery. There is a lot of definitions of EOR as well. One of the important things is that we need to know the mechanism of EOR or EOR methods. So, for example, if you do have a chemical EOR such as surfactant, polymer, or alkaline, the mechanism for surfactant, main mechanism, it will be the weightability alteration, and also it will be for interfacial tension reduction and also for a deep penetration. When we use polymer, the main function it will be to increase the water viscosity, which lead on improving of its efficiency. When we use alkaline, that means the alkaline will generate an in situ surfactant in order to reduce the IFT. For the thermal EOR methods such as steam flooding, CSS, hot water, and in situ combustion, and downhole heaters, the main function for thermal method and the mechanism of the thermal EOR method is to reduce the viscosity, and accordingly the mobility of the oil will be improved. For miscible gas injection such as CO2, natural gas, nitrogen, and so on, there is the function and mechanism for miscible gas injection is the diffusion, the extraction, the pressure maintenance, oil viscosity reduction, swelling, and even combination from each of them. For microbial is to generate the biopolymer and biosurfactant, and accordingly the weightability will be alterated in the formation. For using flow salinity water injection, is normally for shale cracking, or it could be used for wettability alteration and IFT reduction, as well as water exploitation. And also, smart water injection normally is used for wettability modification in the presence of air at higher temperature reservoir. There is a very strong relation between enhanced oil recovery and Darcy Law, and this is also will help us in the concept of the EOR and as well for Darcy Law. Darcy Law can be found in two forms. One of them is area multiplied by permeability multiplied by differential pressure, and viscosity multiplied by the length. And also this can be converted to rho GH. So when we are focusing on the differential pressure, that means we are looking for pressure maintenance and sweep efficiency, which will improve also the productivity of the oil. When we are focusing on oil viscosity, mainly reduction of oil viscosity, which lead in improvement of mobility of the oil, and accordingly the production of the oil will be increased. At this case, we are talking about thermal EOR, with the main function and the mechanism of thermal EOR is to reduce the viscosity. Another thing, when we are focusing on the relative permeabilities, that means we are talking about chemical EOR factor, which is reducing as interfacial tension. For the density, here we are talking about miscible gas injection. So, and for if you are this equation also can be for water. When we are focus on viscosity of water, that means we are talking about the polymer EOR method, which is mainly for increasing of water viscosity, and accordingly the mobility of water will be very low, and then at this time the mobility of the oil will be higher than the mobility of water, then we can produce more oil. Also, one of the important equations used for the recovery mechanism is the recovery factor. The maximum recovery factor is the combination of microscopic displacement efficiency multiplied by microscopic sweep efficiency multiplied by connected volume factors, and also besides the economic efficiency factor. So considering for all of these efficiencies and factor, we can get the highest recovery factor. Before implementation of EOR, we need to know what is the field type for this EOR. Do we have offshore field? Do we have onshore fields? So the implementation will be different. And also we have to consider the reservoir types. Do we have a conventional reservoir? Do we have unconventional reservoir? Especially for comparison between conventional and unconventional reservoir. In conventional reservoir is like we do have like sandstone, fractured limestone, and dolomite. And as general in conventional reservoir, the production can be considered as easy and can be produced directly by vertical wells. And then accordingly, the EOR method also will not be complicated compared to unconventional reservoir such as shale, oil and gas, tide, sand, coal bed methane, tar sand, and methane hydrates. And in unconventional reservoir is is low permeability, which is considered as challenging for EOR implementation or for injectivity as well. Why we need EOR now? Because the designing and implementation of any EOR projects take a lot of time, so we have to think of EOR as early as possible, and also even after implementation, the production response for the EOR it will take time to not happen directly. So when we inject, for example, from injector to producer, sometimes it takes a couple of months, even sometimes it takes a couple of years to get response from injector to producer. And as example, this is from SPE, the EOR project timeline, starting from field selection, process to geological study, designing of the volumeter, pilot testing, implementation, and you can get response. All of this stages it will take almost about 10 years to get the response, and to you can like getting indicated of the successful or fail of this EOR method. So EOR should be considered as early as the steps to successful EOR projects. As general phase, the first step is conduct screening, to technical and commercial screening, to select the best EOR method for this field, and then conduct laboratory studies, and then pilot design, including simulation and so on, and then go to implementation. After implementation, we have to do pilot evaluation. If it is successful or not, then we can go for full field study and full field implementation. These steps is very important for the success of EOR projects. The second part, talking about EOR application. Uh, One of the important things for the EOR method selection, you have there is criteria and there is like method. So in order to select the best method for your field, you have to look for your gravity, viscosity, composition, oil saturation, lithology, thickness, permeability, depth, and temperature of your reservoir. And based on this criteria, you can select the best method for your field. Like nitrogen miscible, is it like polymer, chemical, thermal, and so on. So as summary, the factors affecting the selection of any EOR method is the oil gravity, like API, oil viscosity, reservoir depth, reservoir temperature, porosity, permeability, and formation type. The production as general from EOR application from literature Thomas 2008, from as example from USA, EOR produced up to 600,000 barrels per day. An increase is more than 700,000 barrels per day as total. And this contribution mostly come from thermal EOR projects, and then from gas EOR project, and some of this contribution from chemical EOR project. And for other distribution for all the world, based on this study, 30% from EOR contribution come from USA, 22% from Mexico, 16% from Venezuela, 14% from Canada, 10% from Indonesia and China, 7%, and the rest of the world is the current EOR technology status is like in different stages. Some of them is still under pilot stage, like smart watering flooding, still under piloting. Some of them is still under research and development, like hypers, foam, HPI, surfactant, and in-situ combustion is still under research and development. And some of them, this method already has been commercialized and they passed all of the steps of field implementation and pilot evaluation, and now it can be considering full field implementation like steam injection, gas injection, SAGD, and polymers. And one of the is still the microbial, and also I can add here like the nanotechnology can be still considered as in risk area for EOR technology implementation. As summary for the current EOR challenge, one is the first challenge is the nanotechnology application. The other challenge we encountered, like the chemical application of chemical EOR, can be considered as expensive, but it has to be implemented if needed. Just the cost need to be optimized, and also there is sometimes some formation damage has been caused by this chemical. So this is one of the current EOR challenges. Another one is heavy oil at critical depth reservoir. Uh, as much as you know that the critical depth for thermal EOR implementation, like we are talking about 1,500 meters, 1,600 meters, and this depth is the implementation of thermal EOR for heavy oils is very challenging. EOR application in mature field with high water cut. When we do have high water cut and we need to implement EOR, this is very challenging for up to now. Also, there is a limited field application for some methods such as surfactant, microbial foam, and in-situ combustion, and so on. See, also this is still as challenging. There is like still it need to be more field application in order to be commercialized. And when we classify it from compare between onshore and offshore for the challenge of EOR for onshore, all wells, the location of the all wells, the current situation of all wells is very challenging for implementation of EOR for onshore. Besides, if we do have a commingled wells, also the reservoir understanding is very important. Some of the reservoir is very complicated, it's causing like a lot of faults, a lot of fractures. And for offshore also the same, the reservoir description. Besides the logistic of, for example, to mobilize these equipments or material of EOR material to onshore is very challenging. Besides, most of the offshore field has a large unit spacing. This is very challenging for the spacing between injector and producer. In this case, the response will take a lot of time. Also, summary for the recent trends in the EOR. The new trend in chemical EOR includes the application of the nanotechnology. Still is new trend under research and development, and also a trend for the new chemical, such as it can be used as ionic liquids, and the development of improved technology from previous well-known chemical EOR. Even some chemical EOR method has been implemented, but still it need to be improved. Still it need to be developed, especially for the thermal stability of some chemical EOR at critical reservoir temperature like 800 centivolts, 900 centivolts, and above is still implementation of chemical at above this temperature still is challenging for the research and development. Permanent downhole monitoring using fiber optics. This is the current trend for research and development. Beside microbial EOR, smart tracer, delivery of material, especially for offshores, detailed reservoir description, and downhole steam generation. Also, this is one of the new trend or the current trend in the EOR research. Regarding the status of EOR, we can find here from this study comparing to an EOR in 2004 up to 2015, we can see it's clearly globally 131 thermal EOR project has been implemented up to in 2004, and 180 miscible EOR methods, besides 15 EOR projects and the immiscible EOR projects, and the others is less than 10. And there is a clear incremental of EOR field applied up to 2014. If we look at it as a percentage, it has become clearly found that thermal steam injection is a big contribution for the EOR implementation. The thermal steam, just steam, is 42%, besides 4% for the in-situ combustion and 2% for hot water. For gas miscible injection, its contribution is 35%, and for gas immiscible is 6%, and for the chemical 80% for polymer and 3% for ASP. Another classification for weighted EOR per country. The highest country implemented EOR by almost 30% is USA, then China by 26%. This comparison between 2010 and 2014. And also Venezuela 17%, beside Canada 16%, and 80% for Indonesia, 1.7 for other world. But in 2014, we can notice that USA and China almost they have the same percentage of EOR projects, and also Venezuela reduced to 13%, and Canada 15%, and at 2014 Russia is 12% for the contribution from EOR. For worldwide EOR bare formation, we can notice that there is all 78% of EOR implemented worldwide in sandstone reservoir, and in sandstone reservoir most of this EOR method is thermal EOR method, and then chemical EOR method, and then the gas injection method. For the carbonate, the highest is gas injection, same for the others. So for the carbonate contribution is 18%, and this study has been conducted based on almost more than 1,507 worldwide EOR projects. World EOR projects rates it clear from this research. The contribution from thermal EOR projects is reached almost 2 million barrels per day for like average of more than 100 thermal EOR projects, and for chemicals around 400,000 barrels per day for like 5 projects. For hydrocarbon gas injection, the same for CO2 injection with more than 100 CO2 EOR projects. This plot has a detailed breakdown for each type and each method of EOR connected with oil price. So we can notice that since 1986 there is like almost more than 500 active EOR projects, and most of this project is steam injection projects and hydrocarbon immiscible projects and polymer. And we can notice that the EOR implementation is reduced, but when the oil with stabilizing of oil price, but when oil price is increased, then the countries and the companies think again to use EOR. We can notice that EOR implementation again is increased up to 2014. I will just give some example for some countries like in China. Up to 2016, there is totally 375 EOR projects, including 27 thermal EOR projects and 239 chemical EOR projects. In 2016, totally 249 EOR projects, including 8 thermal EOR projects and 218 chemical EOR projects, and in this including only for polymer only 160 EOR projects. And as a percentage, the chemical EOR in China is the highest contribution, is almost 54.6%, and then 43.7% for the steam injection implementation. Another detailed example for the one is the famous example for the chemical enhanced oil recovery is Darcy oil field, and from this research and from this paper we can notice that the first pilot in this field has been tested in 1972, and then after many years, 1991 went for industrial test, and 1996 for a full field implementation. And we can see the EOR contribution is increasing with time. And also this is another example for SPE flooding in same field, that's in oil field. We can notice that the first single well pilot test has been conducted in 1994 after 6 years of single well, and after evaluation, then the second phase of large scale field test in 2000, and after 7 years industrial application field, and after another 7 years the full field implementation. And this journey took almost about 20 years, and we can see the peak for the contribution has been reached in 2014, 2015 and 2016. So this give us indicator EOR implementation is long-term strategy and need to be better for a long example for the EOR projects in the Middle East. As general, we can see that the thermal EOR has been implemented in Sudan, Egypt, Kuwait, in the Mediterranean zone between Kuwait and Saudi Arabia. Also in Oman, there is 3 thermal EOR projects. For the chemical EOR projects has been implemented in Oman, and also for the gas injection in Oman, Emirates and Turkey. Beside there is one other project in Syria. So we can notice that Oman is has a lot of EOR projects, and the most EOR project has been implemented in Oman. So the contribution of EOR to PDO Oman in a study, this study indicate in 2019 52% of production of PDO Oman come from secondary recovery, 37% come from primary, and for EOR 11%. And expected in 2025, the contribution of EOR will be reached 23%. Another example of EOR in Iran. In Iran is a lot of EOR projects. One of this CO2 miscible injection is contribution was 62%, with almost about 40 projects, and then CO2 immiscible is 12%, and then steam injection 12%, and 8% for hydrocarbon immiscible. This table for the recent study has been conducted shows that the breakdown for the chemical EOR projects in USA, Canada, China, India, Indonesia, Germany, Argentina, Australia, Russia, and Oman. And we can notice that the type of the formation here, most of these fields are sandstone reservoir, and for many different type of chemical EOR, and the contribution in some field like in Canada is the incremental reach 62.7% in West Canyon in Canada. And another example in Dacian oil field, the contribution or incremental of oil recovery 19.4 up to 28% of oil in China. This table shows breakdown for some thermal EOR method like in-situ combustion, and this has been implemented in India, Romania, Canada, US, and for steam injection, CSS or steam flooding has been tested in Brazil, Venezuela, US, Indonesia, the former Soviet Union, Trinidad and Tobago, Oman, China, and Canada. For the SAGD, has been tested in Canada, Venezuela, and China. For this table shows a breakdown for the thermal EOR method based on like is it a CSS and steam flooding. So most of this field can be in China. There is some field also in Oman, Kuwait, Argentina, and also beside Indonesia, Turkey. So China has the biggest contribution for EOR for the thermal EOR. Most of this thermal EOR has been implemented in sandstone reservoir. Finally, there is a study conducted by Global Water Intelligence, and it shows that in 2015 the contribution of EOR in the United States is almost 0.6 million barrels per day, and it is expected the EOR that will contribute almost about 2 million barrels per day in the United States. For Saudi Arabia, up to 2015, there is no any EOR projects, but the contribution of EOR will be almost about 1.2 million barrels per day in 2035. In China, currently is like 0.1 million and expected to be almost 0.75 million in 2030 million barrels per day in 2035, and so on for the other countries. Now let us for Sudan, the current status for EOR project. First, you start from the distribution of global oil reserve. Based on this study, we can notice that Venezuela has highest storage reserve in the world, then Saudi Arabia by 266.5 billion barrels per day, then Kuwait, then Canada, and Iran, Iraq, Kuwait. For Sudan, the proved reserve has been this report is 5 billion barrel. So Sudan has like it can be considered as a good reserve compared to, and better than a lot of countries. And another important thing why we need EOR for heavy oil and for Sudan as well. As per study Thomas in 2008, if you do have light oil, 25% can be produced by primary recovery, 30% can be produced by secondary recovery, and still there is 45% is the EOR target. It will not be produced unless we use EOR. When we have heavy oil, 90% from your oil will be targeting by EOR. By primary and secondary, you can only produce as average 10%. And when we have tar sand, like in Canada, we cannot produce anything unless you use EOR. EOR is very important for Sudan and for because most of the of Sudanese oil fields are heavy oils. As a summary for the EOR projects in Sudan, we have two big companies, Gimbuk or 2B and Petroenergy. For Gimbuk, this CSS has been tested in this field beside chemical EOR like CMR, Greenzyme, and multifunction. Also, miscible and immiscible gas injection has been tested beside CSS in HLB field and CSS in LLB. For Greater Higlig, there is a pilot stage still under research and development for ASP chemical EOR, and there is some chemical has been implemented in Greenzyme and multifunction. For the other companies, PDO Energy, for GM field, there is multifunction chemical EOR has been tested. CSS and steam flooding has been implemented in CSS, gas injection and nitrogen injection in GS, and FC, the CSS has been implemented. These EOR projects, they are in different stages. Some of them are in research and development stage, like the chemical EOR in Greater Higlig. This research has been done, EOR, detailed screening, selection of the field, and besides the laboratory study. Since 2012-2013, this study has been finished, but this project has been postponed. Up to now, there is no pilot implementation. Another project is guar gum as used as polymer, and this is research and development has been conducted in 2018-2019 and come up with a suitable polymer can be used for this field. And the screening, the laboratory, the selection, all of them has been done, and now is waiting for field implementation. For the field under the pilot stage, we do have CSS in GMBC since 2014, CSS in Central, and nitrogen in South and Najma, chemical EOR such as Greenzyme, multifunction chemical in Greater Nile and in Petroenergy, and besides the steam flooding in full North East since 2015. There is only one project reached the full field stage in Sudan, is CSS in FNE since 2014-2015. As an example for the EOR performance in Sudan, this is one of the famous fields, FNE field. This production performance since 2010 up to 2016. This is for the green for coal production and the red for steam production. We can see there is clear contribution for steam injection and for CSS wells in the total production for this field. It's very clear, and almost the production reached sometime even the double production has been achieved by the EOR production. This CM has been implemented by mobile boiler, and also the production use most of this will use PP. Again, I need to remind about the general steps for the best practice for EOR. This is 10 steps. It should be followed as a standard, starting from technical and commercial screening, then laboratory study, then pilot designing, and for phase 1, implementation for phase 1, evaluation for phase 1, and then we will come up for pilot designing for phase 2, implementation of phase 2, and then evaluation for phase 2, and finally we will go for full field study and then implementation for full phase. This steps is very important, and based on these steps, we did some evaluation for the Sudan, and one of the challenges in Sudan, this steps is not followed. This is very important in Sudan. We can notice from this table, this is the fields, and this is the EOR method has been implemented in Sudan. We can notice most of Sudanese oil field doesn't follow these steps. Some of this field follow all the steps, and accordingly there is good indicator and good result, especially FNE and full center, and maybe also like bamboo. But most of this field in Sudan, especially for chemical EOR implementation and from gas injection, there is no detailed EOR screening, and there is no detailed designing after laboratory study. So directly from laboratory study, go for implementation, and accordingly, the evaluation for these pilots is not easy to be to evaluate this EOR project are successful or fail. It will not be easy because there is some important steps has been missed. So it is very important to follow these steps in order to be very sure for a long-term strategy and for fulfilled implementation. And now in this slide, we'll talk about proposal for detailed EOR steps, the best practice and example for EOR method. So it's starting from screening, laboratory study, then EOR pilot designing. First, you can start by half and buff, not by flooding. This half and buff, it needs to be implemented. Then evaluation for phase for half and buff, and after evaluation, then we can go for second phase of half and buff, implement of second phase of half and buff, and evaluate of second phase. After this evaluation of second phase of half and buff, then we can go for patterns and for flooding, designing, implementation, evaluation, and then a second phase of flooding, designing, implementation, and evaluation, and finally we can go for full field implementation. This steps, 16 steps, is very important, and it can help to give indicator for the successful or fail at early stage. And unfortunately, most of these red steps has not been followed in Sudan. Accordingly, the EOR project is very challenging, and there is no like a clear plan. Either it is success or some of them are success, some of them are failed. So it is not easy to decide for long term. In this slide, I will give a list of the current challenge for Sudanese oil field with some suggestion. One is low recovery factors and high water cut. Besides that, there's a lot of idle wells in Sudan. Sand production in Sudan is very challenging, especially in heavy oil field. The heavy oil itself is very challenging. There is a lot of bypass and remaining oil in Sudanese oil field. We do have a lot of melt layers and commingled production. One of the challenges in Sudan is low performance of horizontal wells, high GOR, and how to deal with, especially for artificial lift with high GOR, and production below bubble point. As a quick suggestion for this challenge, we need to think about using of EOR method for water control. It can be used like chemical and mechanical methods. For the ideal wells, the assumed production for this ideal wells to be as soon as possible. It will help to sustain the production. For the sand problem, you can use sand control and management methods. For the heavy oil, the thermal EOR method is recommended. For production initiatives need to be considered. This is very important, and also advanced production technology is very important, like Y-tool and dual SP is very important for Sudanese oil field. And horizontal wells it need to be studied and need to be optimized in order to get the high recovery and high production from these wells. Besides, pressure maintenance is very urgent for a lot of fields. There is low pressures like water injection, gas injection, and that is very important. The estimation for the contribution of EOR production in Sudan, as per the report, Sudan has 5 billion. So if we assume that 40% from total field from Sudan is light oil and 60% is heavy oil. So if we 40% from this oil, that means we are talking about 2 billion barrel. And if you are targeting from EOR just 10% from oil, that means we are talking about 200 million barrel. And for heavy oil, we are talking about 300 million barrel. Totally 500 million barrel can be produced if you consider EOR implementation in Sudan. The breakdown, if we consider for like 30 years, so every year we can produce 6.6 million barrels. That means from light oil, and 10 million from heavy oil can be produced from EOR, with total of 45,662 barrel per day can be as a daily oil production from EOR contribution. And if you consider 2020, the current daily oil production in Sudan is 72,000 only. That means the contribution of EOR could improve the Sudanese oil recovery up to 63%, and the total will jump from 72 to be 176 if you only consider the EOR. If you consider the other methods, so the Sudan oil production can be much higher. And here in this slide is just estimation of how much should be the oil production from Sudan as estimation. And from this report, from fact looked on this website from CIA USA, we can found that Sudan is like in the list of in this report we can find the list of reserve for all countries worldwide. So Sudan is number 24 with 5 billion, and other countries below has less less than Sudan, like India, Vietnam, Egypt, South Sudan, Malaysia, Indonesia. And in another slide we can see the production of these countries based on this report. So this report up to 2018 for Sudan, we can find the production is like just 95. This is 2018, but in 2020 now it's 72 only. So from theoretical calculation and consideration, if you consider the annual offtake and 1% up to 5%, and I think this is reasonable and this is achievable and already has been achieved in many countries. So from theoretical calculation, if you consider 5% from oil as annual offtake for Sudanese oil field, we can produce 25 million barrels as cum oil. That means 686,000 barrels per day. I know this figure is very big, but it is achievable and it can be, but it needs a lot of effort should be done. If you just consider 1%, Sudan production can be up to 136,000 barrels per day. If you just averaging of 2.5%, it's 342,000 barrels per day. And I can show another example for some countries. It has even like UK, United Kingdom has only 2.5 billion, but the production is almost 1 million barrels per day. So this is achievable. Another example is Oman. Oman has only 5.3, almost same like Sudan, but the production is 979,000 barrels per day. Another example is India with 4.5 billion. The current production is almost more than 700 barrels per day. Another example is Indonesia with a lot of fields, same like Indonesia, with only 3.3 billion, but the production is also 772,000 barrels per day. So many examples, I can show a lot of examples for many countries achieve this annual offtake, and this production can be achieved. And I hope this to be considered, especially for the term management. So finally, as summary, EOR technologies exist to reduce the project technical risk, and EOR can make a much more significant contribution to the world oil supply, even better than the currently forecasted, and also will be a significant contribution for Sudanese oil field as well. EOR is long-term business, and also it's very important to have a cooperation between international operating companies and national oil companies. So this will result in a mutual benefit between international and national companies and for the countries. As a conclusion, EOR method must be studied carefully to assure proper selection and implementation. The implementation of EOR method is a must to maximize the production and recovery factor from Sudanese oil field as general. The thermal EOR method is the most used EOR enhanced oil recovery around the world and in Sudan as well. Most of the Sudanese oil fields are heavy, which represent about 60% of reserve. And the EOR target for this heavy oil in Sudan is up to 90% from oil and 45% for the light oils. Most of the EOR projects in Sudan doesn't follow, unfortunately, the best practice for EOR implementation, and accordingly the evaluation for success rate will not be easy. And the results shows that CSS project is very successful, and most reward double production from FME and pump. The recommendation to achieve the highest advantage from EOR technology, it is highly recommended to localize the EOR like equipment, material, local staff as much as possible. This will help to reduce expenses and to get the highest recovery and the highest benefit from EOR implementation. EOR should be studied carefully, implemented by the optimum way at the right time, and EOR could improve the Sudanese daily oil production, and it can be as increased up to 60%. Sudan has peak oil like 5 billion, and there is potential to increase the current production at least to double 140,000 barrels per day by better implementation of EOR and EOR method, and this should be implemented at one time. This is the reference used for this presentation. And finally, I would like to thank you and thank SPE Sudan section for organizing this webinar. Thank you.